Good morning, children. Last time in the class I had given you some numericals to do, and today we will start the class by discussing those numericals first. So, you should keep a copy with you and just if you have done them, just verify, otherwise see that you copy all the solutions properly. So, the question that I had given was, first one was a solid object of density rho and weight W is completely immersed in a liquid of density rho L. Show that now its apparent weight will be given by W into 1 minus rho L upon rho. So, children, in the question what is given to you is the weight is given to be W, density is given to be rho, and the density of liquid rho L. Now, we know the relationship that upthrust is equal to weight in air minus weight in water. Now, when I need to calculate the apparent weight, that is what is the weight in the water. So, what will I have? Weight in water or the apparent weight is equal to weight in air minus upthrust. Now, we know the weight in air is W, but we need to calculate the upthrust. To calculate the upthrust, we need the volume of the solid. So, let us find out the volume first. So, the volume you know is given by mass upon density, that means W upon rho. Now, upthrust. Upthrust is equal to immersed volume into density of liquid into G. Immersed volume, we have calculated the volume of the object to be W upon rho, and since it is completely immersed, so immersed volume will be W upon rho into density of the liquid. Density of the liquid is rho L, and instead of this upthrust, instead of writing the converting into Newton, we can write W upon rho into rho L GF. That means this is going to be in GF now. Now, gram force. Now, come back to this equation, weight in water is equal to weight in air minus upthrust. So, apparent weight is equal to weight in air minus upthrust. Now, what is the weight in air? W, upthrust is W rho into rho L. We can take W common. So, this gives us 1 minus rho L upon rho. This is what you needed to prove. So, now we know the apparent weight of the body will be W into 1 minus rho L upon rho. The next question in the exercise was relative density of platinum is 21.5. Relative density is equal to 21.5, and what you needed to calculate was density of platinum in CGS and SI unit. So, there was not anything much to do in this. In the CGS unit, what will you have? You just have to write this number and put the unit as gram per centimeter cube, and the density in SI unit will be 21.5 into 10 to the power of 3 kilogram per meter cube. So, this is the density in the CGS unit 21.5 and this is the density in SI unit 21.5 into 10 to the power of 3 kilogram per meter cube. Then the next question is, a piece of metal weighs 44.5 GF in air, 39.5 GF in water and 37.5 GF in a liquid. You need to find the relative density of the metal and the relative density of the given liquid. So, now you have weight in air. This is equivalent to 44.5 gram force. Then weight in water is equal to 39.5 gram force and weight in the given liquid is equal to 37.5 gram force. Now, children, you need to find the relative density of metal and you need to find the relative density of liquid. So, first let us find the relative density of metal. Relative density, you all must be remembering, is weight in air upon weight in air minus weight in water. So, now just substitute the values. So, you have 44.5 upon 44.5 minus 39.5. So, this is equal to 44.5 divided by 5. This will give you 8.9. So, the relative density of the solid is coming out to be 8.9. So, now the relative density of liquid is given by weight in air minus weight in liquid upon I will have weight in air minus weight in water. This is the formula. You just need to substitute the values. You will have 44.5 minus this is 37.5 upon 44.5 minus 39.5. When you subtract these two, you are going to get 7 and this is 5. So, what you get answer as 1.4. So, the relative density of the liquid is coming out to be 1.4. Okay, now children, the next question. A solid weighs 30 GF in air. Let us keep writing. Weight in air is equal to 30 GF. Then you are given 26 GF in a liquid. So, weight in liquid is equal to 26 GF and then you have the density of the liquid. So, density of liquid is equal to 0.8 gram per centimeter cube. These are the three things that are given in the question. With the help of these three things, you need to find out the upthrust, volume of the solid, density of the solid and relative density of the solid. So, let us do the first part. A part wants us to find upthrust. Okay. So, we all know that upthrust is equal to loss in weight. Now, this loss in weight, how will I get? Weight in air minus weight in liquid. So, I have 30 minus 26, 4. So, the upthrust that I am getting is 4 gram force. So, B part, what you need to calculate is the volume. Now, for that we will use upthrust is equal to immersed volume into density of liquid into G. Upthrust we have already calculated as 4 gram force, immersed volume we can substitute as V, density is given as 0.8 and into G. So, from here I will get volume equal to 4 upon 0.8. So, this is going to give me 5 centimeter cube. Now, remember over here one thing, this upthrust I have written 4 gram force and here this value of G, if I want to use the value of G over here, then remember I will have to use the value of G over here also. So, we do not use the values of G on both sides, and other way you can write is upthrust is equal to 4 into G and this G will cancel. So, you will get the volume as this only. So, normally in these type of questions we do not convert the given weight in the SI unit, we leave it in gram force or kilogram force for convenience, and that is why when this G is also not substituted, it gets cancelled out on both sides. Now children, in the third part we need to calculate the density of solid. Now what is density? Mass upon volume. So, mass is given to be, now see when I use only 30, that is the mass. So, mass is 30, volume we had just now calculated to be 5. So, the density of solid comes out to be 6 gram per centimeter cube. And finally, what you need to calculate is the relative density of solid. And we all know that relative density will be equal to density of solid upon density of water. So, 6 gram per centimeter cube divided by 1 gram per centimeter cube. So, relative density is coming out to be 6. Finally, the next question is, a jeweler claims that ornaments prepared by him are of 22 karat gold and the relative density of ornaments is 18.43. Ashok purchased a long chain weighing 44.58 gram from the jeweler. The weight of the chain was found to be 41.96 gram force when immersed in water. What is the relative density of the chain? And then you need to find, is the claim of the jeweler correct? Now, once we know the relative density, we will eventually know that the claim of the jeweler is correct or not. So, let us find the relative density first. So, we know the relative density of gold will be equal to weight in air upon weight in air minus weight in water. We just need to substitute the value. So, weight in air is given to us as 44.58. So, again we will have 44.58 minus the weight in water, that means 41.96. So, we will have 44.58 divided by 2.62, and when you divide these two, you will get it as 17.01. So, the relative density of the gold chain which was purchased is coming out to be 17.01. Now, see, The relative density of the ornaments they are telling is 18.43. Now, you can see that the relative density that we have calculated is only 17.01. Actually, it should have been 18.43. So, when you are asked is the claim of the jeweler correct, that means if the jeweler is claiming it to be of pure gold, is he right? So, the answer is no. And why? Because relative density of chain is less than the relative density of the ornaments. Okay children, finally the last question. I feel this you might have found it difficult, but since it is there, let us do this also. A cork piece weighs 6.5 gram force in air. To determine its relative density, a lead sinker of weight 43 gram force is used. The cork and sinker together weigh 11.5 gram force in water. If the relative density of lead is 11, find the volume of the sinker, loss and weight of the sinker when immersed in water, weight of the cork in water, loss and weight of the cork, and the relative density of the cork. So, let us do this. First, let us have weight in air. This is given to be 6.5 gram force. Then weight of sinker is equivalent to 43.0 gram force. Then weight of cork and sinker in water is equal to 11.5 gram force. So, first you need to find the volume. So first you need to first you need to find the volume. That is what has been asked. So, we all know volume is equal to mass upon density. That means mass, we had to find the volume of the sinker. The weight of the sinker is given to be 43, right, and the density of the sinker, density of the lead is given to be 11. This is given in the question, this value is given in the question that the density of lead is 11. So, now this when you calculate, you are going to get as 3.90. So, now I have the volume of the sinker to be 3.90 centimeter cube. Now, the second part, we will remember relative density is equal to weight of solid in air upon loss of weight in water, right. So, this is a general formula which is applicable to find relative density of any solids. So, we are going to apply it to the lead sinker. We will apply this formula to the lead sinker. So, relative density of the lead is given to us as 11. The weight of the sinker in air is already given us to be 43, and loss of weight in water, that is what we need, loss of weight in water. So, we have loss is equal to 43 upon 11. When you divide this 43 upon 11, you will get it as 3.9. So, 3.9 gram force is the loss of weight of the sinker in water. Now, the C part, now children, loss in weight is equal to what? weight in air minus weight in water. Fine. Now, the weight in air is given to be 43. You do not know what is the weight in water. This we had calculated loss in weight just now as 3.9. So, this will give me, this equation will help me to find the weight in water. So, now what is the weight in water? Weight in water will be equal to 43 minus 3.9. This is giving us 39.1 gram force. So, this we have found the weight of sinker in water. Basically, your third part of the question was requiring you to find loss in weight of the cork. So, we needed the weight of the sinker in the water, that is why we have used this. Now, you come to weight of cork in air. Sorry, we will calculate now the weight of the cork in water. So, now you need to know the weight of cork in water. So, this will be weight of cork and sinker in water, right, minus weight of sinker in water. Now, see, usually we were given the weight of sinker in water. In this case, the weight of sinker in water was not given in the question. So, that is why we have used this way first to calculate the weight in water. Now, weight of the cork in water we will get, since we know the weight of cork and sinker in water and we have already found the weight of sinker in water. When we subtract 2, what are we left with? We will be left with the weight of cork in water. So, you just need to put the values. This will be equivalent to 11.5 that was given in the question, then minus 39.1 which we have calculated just now, and this is giving us minus 27.6 GF. Why is this negative sign coming? This negative sign is there to indicate that there is upthrust is too large. The net force is acting in the upward direction. The negative sign is here is only indicating the direction. Now, finally, loss of weight of cork in water. This will be equal to weight in air minus weight in water. Fine. So, what we will have, weight in air is given to us as 6.5 minus, and you had calculated just now the weight of the cork in water as minus 27.6. This is what we had calculated. So, now 6.5 minus and minus will become plus 27.6. So, you will get this as 34.1 gram force. So, this is what is the loss of weight of cork in water. Now, you know relative density is equal to weight in air upon, I can write directly as loss in weight. So, weight in air is 6.5, loss in weight is 34.1. So, this will give me 0.19. So, the relative density of the cork is coming out to be 0.19.